Section 3.3, parallel and perpendicular lines. In this theorem, if two lines are parallel to the same line, here I have P that is parallel to Q and R that is parallel to Q. When this occurs, then they are parallel to each other. Therefore, I can state that P is parallel to R. So I could have just one symbol for all three lines, so they represent that they are parallel to each other. I also could prove that quickly by dropping a transversal. I know that P is parallel to Q. Therefore, I know corresponding angles are congruent. I also know that R is parallel to Q. And I know that these corresponding angles must be congruent. I know that from the corresponding angle postulate in our previous section. But what generates is vertical angles are congruent. Therefore, I know that all three of these angles would be congruent. And that would generate parallel lines by the converse of the corresponding angle postulate. In this theorem, in a plane, if two lines are perpendicular to the same line, here I have P perpendicular to R. And I know when two lines are perpendicular, they intersect to form right angles. I also know that Q is perpendicular to R. Again, they intersect and form right angles. And what I have in the diagram is two lines and a line that intersects both of those lines. That is a transversal. When two lines are cut by a transversal and corresponding angles are congruent, then these two lines must be parallel. Therefore, the theorem states then the two lines are parallel to each other. Q is parallel to P. Our next theorem, in a plane, if two lines are perpendicular to one of two parallel lines, then it is perpendicular to the other. Here I'm given that R is perpendicular to P. R is perpendicular to P. Two lines that intersect and are perpendicular form right angles. I know that Q and P are parallel. And I also know when two lines are parallel and are intersected by a transversal, corresponding angles are congruent. Therefore, this angle must be a right angle. These two are corresponding angles. If that's the case, if two lines intersect to form right angles, then they must be perpendicular. We can verify that in a proof. Here I'm given that R is perpendicular to P and Q is parallel to P. And that's our given information. We want to prove R is perpendicular to Q. I'm given that the measure of angle 1 is 90 degrees. I know 1 is the angle intersection by R and P. That is the definition of perpendicular lines. Perpendicular lines intersect to form right angles. Number 3, angle 1 is congruent to angle 2. Well, I know that Q and P are parallel. These two angles are congruent because of the corresponding angle postulate. If two parallel lines are cut by a transversal, then corresponding angles are congruent. Then I can state that the measure of angle 2 is 90 degrees. I know that because of substitution. Since the measure of angle 1 is 90, and angle 1 and 2 are congruent, I can then substitute to say that measure of angle 2 is 90. And when two lines intersect to form right angles, they must be perpendicular. Definition of perpendicular lines. For this exercise, if A, B, C, and D are distinct lines in a plane, each exercise below has a combination of relationships between the lines. You are to determine how A and D are related. We can do a diagram that will support the theorems from the previous slides, or we can just use the theorems from the previous slides. Let's just use the theorems. Here I have A is perpendicular to B, and A is perpendicular to C. If two lines are perpendicular to the same line, they must be parallel. Therefore, B is parallel to C. I also have that B is parallel to D. And if two lines are parallel to the same line, they are parallel to each other. So I have C parallel to D. I know that A is perpendicular to C. And I know if a line is perpendicular to one of two parallel lines, it is perpendicular to the other. Therefore, A is perpendicular to D. Let's verify that with a diagram. I have that A is perpendicular to B. And A is perpendicular to C. And you can see by the corresponding angle postulate, it's converse, that these two lines must be parallel. If corresponding angles are congruent, then the two lines cut by transversal must be parallel, which I have here. I also have that B is parallel to D. Then I know that all three lines are parallel. And if that's true, then I know that this must be a right angle, because if two lines are parallel, then corresponding angles are congruent. So this is a right angle. Then I know that D intersects with A and forms a right angle, and that is the definition of perpendicular lines. Therefore, A must be perpendicular to D. Number two, I know that A is parallel to B, and B is perpendicular to C. And I know if a line is perpendicular to one of two parallel lines, it is perpendicular to the other. So I know A is perpendicular to C. I'm also given that C is parallel to D. Again, if a line is perpendicular to one of two parallel lines, it must be perpendicular to the other. So I know that A is perpendicular to D. Again, we can verify this with a diagram. I know that A is parallel to B. B is perpendicular to C. If this is true, I know that these two lines are parallel. Then C must be perpendicular to A because of corresponding angles being congruent. If this is 90 degrees, this is 90 degrees, and since these two lines are parallel and cut by transversal, the corresponding angles are congruent. So I know A is perpendicular to C. I'm also given that C is parallel to D. And if that's true, again, I know the corresponding angles are congruent. Therefore, this is a right angle. And when two lines intersect to form right angles, they must be perpendicular.